So we're going to start our stoichiometry unit today, and our first learning target, 7.1, we're going to learn how to correctly write and balance chemical equations. So you need to know why equations have to be balanced, the different parts of the equation. You need to know how to convert word equations into formulas, which is just formula writing, and you need to know how to balance them. So a balanced chemical equation, we need to start with the law of conservation of matter. It says matter cannot be created nor destroyed. We can, however, rearrange it. So there's two reasons that our equations must be balanced. Okay? First reason is to satisfy this law of conservation of matter. What we start with, we have to end with. We can't lose it anywhere. The coefficients of the balanced equations are going to give us our mole ratios, and we're going to use that with stoichiometry. So there are a couple of reasons why we have to balance chemical equations. So, general form of a chemical equation, we're always going to have reactants on the left of this little arrow and products on the right. So a reactant must react to produce a product. So some symbols that you need to know, these are going to tell us states of matter which will affect the outcome of an equation. You're going to need to know them, and then we're going to kind of back off of them. But they're pretty simple. Little s means solid, little l means liquid, little g means gas. If something has an AQ, that means we've taken a solid and dissolved it in water. The arrow means yields or produces. Now, you need to know the diatomic atoms. These atoms do not ever exist by themselves. They'll either exist as a pair or they will exist with another element in a compound. And we kind of call them the Brinkelhoffs sometimes. And this is a little an acronym for you. If you look on the periodic table, they form the 7 here, starting with the 7, and hydrogen. So you need to highlight your periodic table. You'll notice the one in the classroom is highlighted in green so that you'll remember these. Alright, so here's our first problem. You should have this one that I gave you in class. If not, you should have been able to print a copy from Schoology. So hydrogen gas reacts with oxygen gas to produce water. So let's start by writing hydrogen gas. Now hydrogen is one of those Brinkelhoffs, the diatomics, that we just talked about. So hydrogen will have to be in a pair as H2. Alright, now I always put a blank in front to remind myself I need room to balance my equation. And because it's a gas, I put a G here. Now reacts with, we're going to use a plus sign. Oxygen gas is also one of those Brinkelhoffs, one of those diatomics. So we're going to write it the same way as an O2 and a G for gas. To produce is my arrow, and then water. Now water is a liquid, so we put that there. It's not dissolved in water, it's just water. Now to balance this equation, what we have to make sure we do is that every reactant, so hydrogen and oxygen are called reactants, balances out to all of our products. So water is the product here. So we're going to use the arrow as our dividing line, and we want to count our atoms and make sure that our atoms add up on both sides. Okay? So to do that, what I want you to understand is that you cannot break apart any of these compounds. If you break apart compounds, you totally change it. You can't just add a subscript on here either, okay? Because H2O2 is hydrogen peroxide, and if you drink that, of course, you'll die. So you can't just throw a 2 on there. So what you can do is add more of what you have. So if we break this down and we say the H2 looks like this, HH, and O2 looks like this, OO, and H2O looks like this, HHO, then what we can do is add more of what we have. So if we have 2 waters, then that means I have 2 oxygens. But now it also means I have 4 H's. So if I go back over here and look and see that if I have 2 H2s, then I have 4 H's. And we are going to look at this as a mole ratio. And what we're going to do is count the number of our atoms that make this equation balanced and use those as coefficients. So if we count, we have 2 H2s, so we're going to put a 2 on our blank here. We have 1 O2, so we're going to leave that blank, and it's understood to be 1. And we have 2 waters here. And these coefficients balance out our number of atoms. So we have 2 moles of hydrogen to 1 mole of oxygen to 2 moles of water. So we write those coefficients over here as 2, 1, 2. That's just an easy way to help us go over these instead of calling out the whole thing. So what you need to remember is that these coefficients here are the mole ratios of these things. Alright, so let's look at this next one. Copper 2 chloride dissolved in water reacts with aluminum to produce aqueous aluminum chloride and copper. So copper 2 chloride, we're just going to write the formula. So remember that copper is a transition metal. Its charge is +2. Chloride is chlorine with a -1 charge. So we flip those. Dissolved in water means that it is aqueous, reacts with aluminum. We just put aluminum. Okay, it's not one of those that we highlighted, it's just aluminum. To produce aqueous aluminum chloride and copper. So here's what that equation looks like. So we wrote the formula, copper's a +2, chlorine's a -1, so we get a 1:2 ratio. Aluminum, just like that, and aluminum is solid. Aluminum chloride, aluminum is +3, chlorine is -1. So notice we have Cl2 here and Cl3 over here. Remember to use the charges in every single formula. Okay, so because we have aluminum and chlorine here, it's a 1:3 ratio. And then we have copper, and it was a solid. Now this is the reaction that we did way back at the beginning of the semester, where we put aluminum foil in the copper chloride. Now if we look at our balancing, we have CuClCl, we have aluminum, AlClClCl, and copper. Now anytime you have elements by themselves, you're going to want to do those last. And as you practice this equation balancing, you will get better and better, and you will learn tips and tricks. Okay, so that's one that I can tell you. If you have an element all by itself, save it till last. Okay, now if we look at the chlorines, okay, we see 2 chlorines here and 3 chlorines here. We got to think logically. There's no way we're going to get 3 chlorines here, because we can't just add half of a CuCl2. There's no way we're ever going to get 2, or even, we're never going to get 2 chlorines over here. So what you can do here is look at a number that both 2 and 3 go into, which is 6. So if we have 3 CuCl2s, and if we have 2 aluminum chlorides, then we have 6 chlorines on both sides. Now we can fix our copper. We have 3 coppers here, so that means we have to have 3 coppers on the product side. We have 2 aluminums on the product side, so we need 2 aluminums on the reactant side. So now everybody is balanced, so my coefficients are going to be 3, 2, 2, 3. Okay, so we would write it like that. Now let's just look at some equations to balance. Okay, so let's practice this. So if we start with sodium iodide, now when you have a polyatomic ion and you see that polyatomic ion on both sides, you can leave it whole. Okay, so we can write this as PbSO4SO4 because there's 2 SO4s there. Alright, so we have Pb and 4 I's. Then here we have 2 sodiums and a sulfate. So if we just start going left to right, which is usually the easiest thing to do, we have 1 sodium in the reactants, we have 2 sodiums in the product. So if we add another sodium iodide, then we have 2 sodiums. But if you notice, we have 4 iodines in the product side, which means we're going to have a total of 4 sodium iodides there. So then we go back over here, and if we add another sodium sulfate, then we will also have 4 sodiums. So notice that the sulfates now we have 2 there and 2 there. So 4 NAs, 4 NAs, 4 I's, 4 I's, 1 Pb, 1 Pb, and 2 sulfates. And that is going to give us a balanced equation of 4, 1, 1, 2. So let's look at the next one. Alright, now this one is a little different because in our product side we have oxygen in 2 different compounds. Alright, so I'm also going to show you a little shortcut that I use. Instead of writing CC, I just write 2 C's, 6 H's. Okay? Now I'm going to leave the others as OO. That's pretty easy to write. COO and HHO. Alright, so if we just start on the left, 2 carbons. So if I add another CO2, that gives me 2 carbons. I have 6 hydrogens, so I would need a total of 3 waters to give me 6 hydrogens over here. Now if we count our oxygens, we have 1, 2, 3, 4, 5, 6, 7 on our product side. Now, are we ever going to get 7 oxygen from an O2? No, we can't. So if that happens, the general rule is just to double everything. Okay, and these are ratios, so if you get something that can be reduced, you'll reduce it at the end. It's no big deal. So if we start by doubling our, this is ethane here, that means we have now 4 carbon and 12 hydrogen. So I'm going to need 4 CO2s to get 4 carbon, and I'm going to need 6 waters to get 12 hydrogens. Okay? Now if we count our oxygens, we have 1, 2, 3, 4, 5, 6, 7, 8 there, 9, 10, 11, 12, 13, 14 total on my reactants. So how many O2s would we need to get 14? We would need a total of 7. So our coefficients are going to be 2, 7, 4, 6. Now, like I said, if you get something that can reduce, like you say, you get 4, 14, 8, and 12, that reduces to 2, 7, 4, 6. Let's look at one more example. Alright, so in this equation, we've got our aluminum by itself. Now notice we have hydrogen in the same compound, but in 2 places. So what I'm going to do is combine those. So I have 1 carbon, I have 4 hydrogens, and I have 1 oxygen. Now over here, this 3 is going to multiply by each subscript inside. So I'm going to end up with 3 carbons, 9 hydrogens, and 3 oxygens, and then my aluminum. Then over here I have my HH. Alright, so where do I start? We don't want to do aluminum, it's by itself, and we want to save hydrogen because it's by itself also. So that leaves carbon. So let's start with carbon. If we have 3 of the CH3OHs, then we have 3 carbon. Okay, so then if we start adding up our other things, we end up with 12 H's there, and we end up with 3 O's. Okay, so everything balances except for our H's, because I have 9 H's here, and I have 2 here for a total of 11. Now what we have to notice is because we have actually 4 hydrogens in this compound, you're never going to get an odd number. So the easiest way to get rid of an odd number, multiply by 2. So let's start by doubling everything that we just did. So if we double this, now we have 6 carbons. So if we go back over here, we need 6 CH3OHs to have 6 carbons. Alright, so now if we count our oxygens, we have 1, 2, 3, 4, 5, 6 oxygens on our reactant side and 6 oxygens on our product side. So we got to look at our hydrogens. We have 1, 2, 3, 4, 5, 6 times 4 is 24 H's. Okay? Now over here we have 18 H's in this compound. So that means we need 6 more to come from H2. So if we have a total of 3 H2s, then we have 24 total hydrogens. Okay? Then we have to go back and notice that we have 2 aluminums on this side, so we need another aluminum here. So if you count all of your aluminums, carbons, hydrogens, oxygens, you will see that they all balance out. So my coefficients are 2, 6, 2, 3.